Problem 1461. Check if a string contains all binary codes of size k. So let's just first check this example. So if k equals to 2, so what is the binary code? So it's going to be 0, 0, 0, 1, 1, 0, and 1, 1. So that's going to be all the combinations while k equals to 2. We just need to check if inside the string S we can find all those substrings. So for example, this is 0, 0, and this is 0, 1, and this is 1, 0, and this is 1, 1. If we can find all of them, basically we're going to return a true, otherwise it's going to be a false. So the maximum of the k is going to be 20. So for solving this problem, if we are going to check all combinations of this k, so if this k equal to 20, basically it's going to be 20 binary base. It's going to be a really big number. It's going to be 2 to the power of 20 different cases. And yeah, we have to check if each case is inside of the string. Definitely it's going to be time limit exceeded. So instead of solving that directly, so we're going to solve it reversely. We just need to check if inside of the string S, if we can find all those subsets. So for example, if k equal to 2, it's going to be those four cases. So we just need to put those cases inside the set. If the set is equal to 4, it means it is okay. Otherwise, it is not okay. So we're going to use basically use a sliding window method. So we're going to check 2 by 2, 0, 0 inside a set. We're going to put it inside a set, and 0, 1 we're going to put it inside a set, and 1, 1 we're going to put it inside a set. So this is inside a set, this is inside of the set, and then 1, 0 is also inside of the set. So the length of the set is going to be equal to 4. And 2 to the power of k, it's going to be all the different cases. If this is equal, so it's going to be a true, otherwise it's going to be a false. So this is just a O(n) time solution. Yeah, even though sometimes we're going to say this is not O(n) time because we're going to check a string inside a hash, but basically we're going to understand it as O(n) time. So if the length of the string, for example, it is 20, so maybe we're going to say it is O(n) times 20, so that's going to be the time complexity. But basically we will not do that. We just understand it's going to be O(n) time. Yeah. And even though this times the length of it, it's going to be 20, it's going to be like 1 times 10 to the power of 7, it should also be okay. Yeah. But anyway, we're going to understand this time complexity is going to be O(n) time. We are going to check if a string is inside a set or not. Even though the string can be very long, the length can be 20. Now let's just use this kind of method to solve the problem. So first of all, we're going to check the length of the string. If it is less than k, basically it means it is not possible. Now we're going to check the length of the set. I'm going to use S set. I'm going to call it S set equal to 2 to the power of k. So this is going to be my final return. Now I'm going to use basically sliding window method to check if it is okay. So for I in range length of S, I'm going to check if I'm going to add it inside of the S set. So I'm going to prepare an empty set. I'm going to call it S set. It's going to be a set, empty set. So as said, I'm going to add all the possible strings. It's going to be starting from I to I plus k, because the length of the string going to become k. I just wanted to calculate how many different of them, and I'm going to put it inside a set. Yeah. But for here, if we use this kind of method, basically while we are checking here, so the length is going to be 1, but we still put it inside of the set. So we don't need to have the further check. So basically we're going to control it from here. So from the length, it's going to be a minus k plus 1. Yeah. I think everything should be okay. So for the first example, so the length of the string minus 1, the length of the string, if we don't have minus k plus 1, it's going to be here. This is going to be the last index. So if we use a minus k plus 1, so k equal to 2, minus 2 plus 1, it is a minus 1. It means the index going to be, the last index going to be from here, this 1. So the length of this 1, 0, it is a 2. It means it is okay. Yeah. So this is the final solution. Now let me just run it and submit it. yeah, as you can see, it works and it's pretty fast, and the time complexity and space complexity gonna be O(n). So for this problem, actually, while we find if we do it directly, it's gonna be difficult, but why not just do it reversely? So instead of checking all cases from this k, so we're gonna just enumerate from the s. Inside the s, we're gonna check how many different cases. If it is equal to 2 to the power of k, basically it's gonna be true. Otherwise, it's gonna be false. Thank you for watching. See you next time.